We will now proceed to the keynote speech. Let's welcome Paul Vixie, Vice President and Distinguished Engineer, AWS, who will join us virtually to deliver his keynote address on DNS, resilience, and security in crisis. Ladies and gentlemen, please join me in giving a warm virtual welcome to Mr. Vixie.
Hello, and good morning. Sorry I can't be with you in Taipei today. I will see some of you next week in Kyoto. But in any case, I'm honored to be asked to present today. And I want to talk about some long-term changes which have been made to the domain name system, DNS, which has been the subject of much of my career. But I want to clarify at the outset, although I am certainly an employee of Amazon, as the announcer told you, I'm here today representing myself and should not be seen as a representative of the company today. Very well. In the history of all times, the rule of law has appeared and disappeared in different places at different times. And law, human law, is of course an aspect of government operations. And the most powerful governments are those of nations. Now, after the Treaty of Westphalia, nations were defined in a way that has stood the test of centuries, but which is being tested again now. Specifically, a nation must have borders which its government can defend, and within which that government has a monopoly on the use of force. In other words, if you have competition for who's in charge in there, that's not really a nation quite yet. And outside of those borders, the government can be held responsible for sort of what that nation does. I think everyone in this room, being familiar as we are with the internet, we understand that the internet is borderless. I'm not sure that was intended, but it is the design. And what that means is that the internet does not accommodate the notion of nation-state status, not directly. Of course, nations still, they treat their people, their economy, the things in that nation will be treated by the government as worthy of protection and worthy of the rule of law. But it's very difficult to project that force without borders. And we're going to come back to that in a few minutes, but I want to speak a few more generalities first. Force projection, the so-called domains of operation, has progressed over time. Of course, you see on the screen land, sea, space, or air, space, and now information, where we are now. Each of these was an age, was an era. And if one nation or some pre-national power had superiority in a certain domain of operation, for example, land, they could be challenged by someone else who entered the next domain of operation. We have histories that show that a force which was dominant on land and sea was inferior to a force which was dominant in the air, for example. That has continued. And it turns out that where we are now, the information age, is a domain of operation. It is possible to project force in information. And we see that. In fact, a lot of what we are seeing, both information and disinformation, can be characterized that way. and world affairs are being shaped in that way. Now, there is a hierarchy of values. If you can't have, let's say, information supremacy, you would like to have information parity. If you can't have information parity, you'd like to at least have information awareness. And I'm here today to try to share some of my observations so that more of us can have information awareness. What else we do with that is a matter for our conscience. So we're here to talk about DNS, the domain name system. DNS was famously invented by Paul Macapetras at USC ISI in the mid-1980s. And this was in an era where internet-speaking servers were very large, very expensive, and therefore very few in number. And in fact, one of my colleagues reminded me today that in 1988, there were only a few thousand named hosts, servers on the entire internet. And I think we all knew that that was going to change. Moore's Law and other technical trends informed us that the, computers were going to keep getting smaller and cheaper and therefore more numerous. We hoped at that time that the Internet Protocol Suite would be the main way that we connected all of these things. And there were competing models. It was a lighthearted competition, but nevertheless, we were proud of what we'd done and we wanted to do more. And so one of the things that was obvious was the naming of things that were connected to the internet would not be central. When we went from thousands to millions and now to billions, you can see clearly that it would never have been possible to have a central registry that knew the names of all the things. So the DNS was crafted, I think, expertly so by Dr. Macapetras, and I think is one of the ways in which we have been able to grow the internet so far and so fast. But let's review fundamentals, because I know that not everyone in this audience is a career technologist. Just a few things to know. To be connected to the internet means that a device has to have one or more unique addresses. If you're not a career technologist and you want to think of these as being like phone numbers, you go right ahead. That's not wrong. Every one of these IP addresses is capable of being anywhere. So unlike a telephone number that might have a country code that tells you where it is, IP addresses are not like that. Any given IP address can be anywhere. And not only can it be anywhere, it can move. And there's even some tricks called Anycast, where an IP address can be in more than one place at the same time, which is an accident, but a very happy accident. So if you've heard of BGP, that's how these addresses are found. That's how you know where a given address is at any given moment. But a service that is connected to the internet and is intended to serve, it's intended to be reached, will also have to be associated with some devices that have some addresses. I know that sounds obvious, but it's an important closure to our thinking. But we will not be using these addresses in order to find the services that we want. In fact, increasingly, we don't even know the names of the things we want because they're in a web browser. We click on them and magic happens, and then we are taken to the service that we want, which is the thing we clicked on. And all the naming is hidden from us. But even if we know the name, the addresses are almost always going to be hidden from us. You might type www.igf.tw, for example, But I challenge any of you to remember the IP address that that service has today. And I would warn all of you that it could change tomorrow, whereas the name will be more stable. So that's why we have names, and that's what they do. And importantly, every internet transaction begins with one or more DNS lookups. So every click of your mouse in a web browser, every application that you start, every Zoom call, everything that we do requires the client that is close to us to use DNS in order to find the service which is not close to us. And this gives an interesting property to DNS. It is the gatekeeper to the rest of the internet. Because again, every internet action, every transaction that we perform begins with one or more DNS resolutions. So I think that should give us the idea that in terms of force projection and domains of operations, that in the information space, DNS is a very important system. It must be protected, but it's also a very attractive target. If you can control or surveil or perturb DNS, then that gives you almost the ability to control and perturb the internet itself, at least in the view of some users of the internet for the duration of some attack. Lastly, I want to note that DNS changes. You know, again, the TWIGF web service might move and might need a different address to be associated with its web name, and that's allowed to happen. It doesn't happen instantaneously. It takes some time, maybe a few seconds, maybe a few minutes or hours, for that change to be globally visible. But nevertheless, we understand that change will occur, but that it will occur at a certain limited rate. And as long as it is eventually consistent, then it will serve our purpose. Now, one last technical point before I move on. That eventual consistency and the fact that it changes slowly is what allows it to scale, right? DNS was designed at a time that we only had a few thousand hosts on the internet. Now it serves maybe 100 billion, because we've got a lot of people and we all have different devices and there are a lot of servers everywhere. So we've scaled 8 or 9 orders of magnitude from a system that was designed in the 1980s. And the reason that that's possible is because it is a distributed system with eventual consistency that permits the reuse of answers that have been recently enough obtained. So if you meet Paul Makapetris, you should congratulate him on the success of his invention. This is what the system looks like at its highest level, and it's important to understand this, but it's not, I don't think it's too technically deep, but it matters for the somewhat political considerations that I'll address today. There are only 3 kinds of things in the whole of DNS. There are, at least 100 million servers that I know of. But every one of them is like this, and there are billions of smartphones, but every one of those is one of these. So I'll just explain that the answers, where DNS content enters the system, it comes in at the top, and we call those the authority servers because they're authoritative over a certain part of the namespace, like .tw, for example. And the questions come in at the bottom, usually through a web browser at this point, but that has changed over time and will change again. And so we call those the stub resolvers. That's where questions come in. Now the complicated and surprisingly exciting part of this system is in the middle, the so-called recursive servers or the full resolvers. And that is literally, as shown here, where the questions meet the answers. And that is where we keep a cache, as I told you a moment ago, of recently obtained answers so that we can reuse things, because it wouldn't be possible for the DNS to support the speed of the internet if no prior answer given could be reused, right? There's a certain period during which you have to have access to recently obtained results, and that's where that lives. So if you've heard of public DNS or Anycast DNS, or you've heard of 8.8.8.8 or 9.9.9.9 or any of the others, that's what those are doing. That's what Google is doing. That's what Quad 9 is doing. That's what every ISP does. That is what the Wi-Fi provider in your facility there is doing right now. They're all running recursive servers so that those answers can be obtained and can be cached and can be given to all of the locally connected devices. All of this is well supported by open source software. I want to commend my friends at UC Berkeley Computer Science Research Group, who created really the first open source version of the DNS protocols. It was called Bind, and it was my happy honor to take over maintenance of that starting around 1990. And I gave it up about 15 years later to my newer colleagues at the Internet Systems Consortium, some of which I think are in the room with you. Anyway, that's it. You don't need to know very much more about the DNS, but now that you've seen that, it'll make sense to you to look at a broader picture. In other words, the topology of the system. So you and your smartphones are down there at the bottom. I, with my laptop here speaking to you from California, I'm down there at the bottom. I am a user and I have an application. And I'm speaking to some kind of a local area network, in this case Wi-Fi, but who knows. I don't have a campus, but I have a house, so it's kind of like a campus. And then the campus connects to an ISP, and that ISP is then somehow connected to the internet. And there are some great things to know and stories to tell about how ISPs connect to the internet, especially in Taiwan. But for our purposes, you just need to sort of understand there's a food chain. And once you get to the internet is responsible for getting you to whatever far edge of the universe that you want to get to based on the IP address that you found when you did a DNS lookup. And this is the path that all of your data is going to take to get to the internet. And then there's a very similar path like this at the other end where you come down and actually reach some service. So I mentioned that the DNS is a gatekeeper protocol. It's responsible for most of the transactions, almost all really of the transactions on the internet, and that it's therefore a very attractive place to exert power. It was an opportunity that was seized. And so as an example, in right around the year 2000, there was an experiment of adding a DNS wildcard to the .com zone. And what this meant was there could be no negative answers. When there's a wildcard, it means that if you ask a successful question, you get the right answer. And if you ask an unsuccessful question, you ask for something that isn't there, you still get an answer. It's just maybe not the answer you were hoping for. And so the operator of the .com zone at that time, I think, was trying to grow revenue, and they didn't understand at first how much the world depended on .com giving negative answers when errors were made. So there was a lot of drama. Some of the people that were introduced earlier were sort of present for that. There were lawsuits, there were newspaper headlines. Eventually it was taken out. A few years later, another company, OpenDNS, decided that they would think about doing something similar, which is that if you asked a question about something that didn't exist, it could give you kind of an advertising page. It would assume that you must be using the web, and so it would give you a page that would maybe have some links. You know, if you have an error that involves Taiwan and you misspell that, then perhaps it'll give you a list of airlines that can have flights for you to take you to Taiwan. That would be an example. And then they also had an experiment where they intercepted the requests for www.google.com because that led to a search engine, to an index page where you could type a question. And they thought, well, we can just give our own search page and we can let people type their keywords in, because then we'll know what they were interested in, and then we'll be able to keep track of that for the purpose of advertising optimization. Google took a dim view of this and said, please don't answer wrongly for our name, but in the end, Google simply had to create 8.8.8.8 in order to compete against OpenDNS to sort of get that traffic back. And eventually OpenDNS removed the interception. But those are two examples of how the DNS was seen as a way to gain power and perhaps to increase revenue by interfering with the previous norms. It's not the last time that has happened. So eventually we had, all these different name services like 8.8.8.8 that were no longer at the ISP. They were sort of centralized. And so the content servers, if you imagine going to, some online supplier, vendor, whatever, they might like to know where you're coming from so that they can direct you to the closest server to where you're coming from. Maybe one that'll be in the right language, maybe one that will have lower costs. It could be in your region, it could be close by in terms of the internet ping delay. It could be a lot of reasons. That becomes impossible if you can't see the DNS question, or if you only see it coming from central servers and not from a specific ISP. So in order to solve this and to restore the ability to guess where somebody is coming from, this community devised something called ECS, eDNS Client Subnet, which therefore encodes your IP address, that of the client, of the stub resolver. It encodes that IP address into the DNS transaction so that even if it passes through a central service, the far end will still know where it originated from. This turned out to be a real privacy problem. And so some of the address is obscured so that you can't tell exactly precisely which device it came from, but it's still too much information in my opinion. But this is something that had to be done later in order to restore things that had been, or norms that had been violated. So you should be able to tell from this trend that we weren't doing a lot of centralized planning here. In 2013, Edward Snowden famously made a lot of disclosures, leaked a lot of government secrets, and the next year IETF published an RFC entitled "Pervasive Monitoring is an Attack." And that was the beginning of changing everything, because too many norms had been violated, and it became time for a revolution to then restore norms and or find an equilibrium that would be the new norm. So this shows what I said, is that now, because we have all these recursive DNS servers, those central boxes that I told you about that are at the far end of the internet, rather than at the ISP, those content delivery networks needed something like eDNS Client Subnet. So it's a mess. It was better before. This is just adding complexity to deal with other complexity that we've added, but that's, we're human, that's what we do. So, you know, if you abuse your position as an on-path actor by monitoring DNS transactions and perhaps changing the results of those transactions, you can expect some reactions to that. For example, the IETF created DNSSEC, so we have crypto authenticated content, so you can tell when something has been modified. So ad insertion doesn't work at the DNS level anymore, and this is why. We also created something called DNS over TLS, and this is a way to prevent surveillance or interception or modification of DNS transactions that are in flight. So that's different from securing the data. Here we're securing the transactions. Nevertheless, this was still detectable by network operators. It could, in other words, be blocked in a firewall. And that was a problem for some people. So the IETF next created DNS over HTTPS, which is also proof against surveillance or interception, but it's firewall proof. It's designed to be firewall proof. It is very difficult for a network operator to forbid this. And that means that it effectively disintermediates any control, for example, parental controls at home or company policy at work. That's either a bug or a feature, depending on who you ask. The reactions continued. In 2010, my team back at isc.org created a way to do protective DNS, that filtering of content that you think is dangerous. I told you that in 2014 there was the pervasive monitoring as an attack, and then later we changed the transport layer security itself. So HTTPS and the other encrypted protocols are now able to hide their destinations. So you can no longer have a policy at the edge of your home network or your corporate network that forbids going certain places. And, you know, I want to say I don't love it when governments or ISPs have that kind of policy, but I think parents or owners of companies ought to be able to control how their secure private networks are operated. So that's how I think about that. Then we added the next kind of path security in 2018. In 2020, we had an interesting sort of epitaph of the era written by the IAB itself, the Internet Activities Board, that said the internet is for end users, and goes to some length to explain that there shouldn't be network policy, shouldn't be device policy. It should be up to a human to decide what does and does not happen. The problem is that a lot of humans are intruders or you know, other people that, children, people that you might not want to give loaded weapons to. In 2022, the CISA, it's an agency of the US government, had launched a protective DNS resolver because they understood that not everything that's in the DNS is something that every single end user should have automatic access to, especially if they're a government employee. So it's very interesting to watch the ebb and flow of power and who wants it and who does what to get it. This is what we have now. So we still have those three boxes in the middle. You'll see the protective DNS logic over on the right. And then you'll see that all of that is being bypassed by a DNS over HTTPS on the left. Applications now do their own DNS, and they speak to the recursive server of their choice, and they cannot be stopped by a firewall. And again, this is either a bug or a feature, depending on who you ask. But I would like to warn you that your application maker is capable of deciding for you what DNS server it should talk to. The Mozilla Firefox browser, for example, will bypass whatever name server your laptop might be using and just decide to use one that has been assigned by Mozilla Corporation. And Yeah, it'll have a pop-up to let you know that it has done that, but it will not ask you permission. Again, you can see there's a lot of power to be gained from putting yourself into the DNS resolution path and then changing the way it operates. So there are authoritarian nations in the world, and they have been observed to say that even in the world of information, they will have borders and they will control what happens within those borders, but they are not defensible. In fact, there's no collection of networks wherein a single government is going to have a monopoly on power. You have to be inside of a military agency before you can get the kind of power that you want. It won't work for a public user base. And the government, of course, won't be responsible, cannot be found responsible for the things that come out of a certain part of the internet. That makes no sense. But when power is being taken and used, that is a form of coercion, right? It does not begin with negotiation. It begins with doing that which is possible and then waiting to see how everyone else reacts. And often when you're reacting to that, you're not going to be thinking clearly. It's true. It's as true of nations as it is for each of us. So here's an example of that. When somebody told Russia that, by the way, the internet is about to be unblockable and it'll carry anything to anybody, they said, well, no, we have power, we will use it, this is our policy, and we will enforce it. And I don't think that's going to work out very well for them, but it certainly will cost a lot of money and break a lot of things, because that's what happens when you impose your will on someone else through seizing power, and then they have to do the same to recover the power they've lost. In other words, this looks a little bit silly to me, but it also seems predictable and inevitable. I would like us to think a little more clearly about what will be the response before we decide that we're going to invent new security technologies that is going to disintermediate a government over its own economy, for example. So there's a reason I'm telling you all of this, and that is its complexity. Every time we add another layer of logic, every time we put more computational burden, more ways to violate more norms or to restore norms violated by others, we are adding complexity to a system that is already quite complicated. And so what I'm trying to express here is that N over M is your complexity burden. It's how much you understand out of that which is responsible for your outcomes. And if you add to M, you add more technologies, more devices, more things, you're decreasing your overall understanding level. And as you do that, you are expressing implicit trust in your supply chain. For example, you're saying, yes, I'm letting just any old browser be used inside my corporate network. Are you sure you can trust everything that browser might do? Because maybe it's that browser is coming from a political activist who's going to behave differently and behave ways that your company might not like or that your family might not like. You have to choose your counterparties well, but it's harder and harder to do so because there are so many of them and so many choices that you make. Given that complexity always rises, always has, there's no reason to think it'll stop, I think we need a set of norms that copes well with rising complexity. And these are not those. The story I've told you so far is not an example of coping well with rising complexity. So most of us don't have the luxury of thinking beyond our lifetimes. Certainly in government, it will be the case that most of the people who are in government are only worried about what's happening today or what's going to happen during the years they are there. That's also very true in large companies. If you ask somebody what's going to happen to this company 50 years from now, they'll say, well, I'm going to do the best I can to keep our options open so that we're not doomed 50 years from now, but I won't be here. So, you know, I mentioned the domains of operations, and I mentioned that we're in the information era. This is where we're questing, each of us seems to be questing for information superiority or information parity, or at least information awareness, and then everyone else is questing for that too. And every bit of information awareness that any of us has is that much less information superiority that someone else has. So if what you're trying to do is the traditional model of surveillance, which is to see without being seen seeing, so that you can build a model and predict what others will do, so that you can change the operating conditions and control what those entities will do, you need information superiority, much more so than you need land, sea, air, space superiority. This is where the game of modern humanity is being played, in the information realm. And the things that we build into our smartphones, things we build into our laptops, the passionate open source that I and countless others who came after me have created, and many who came before me have created, what we create as software and what defaults we create in our software is destiny. And that means that a young, as yet inexperienced employee at a big tech company can now make more regrettable mistakes than at any time in history. And I see that playing out in the DNS. You might see it playing out in your part of the internet, but this is my part. So let me just sum up. Classical rule of law doesn't apply where there are no borders. So in the information age, we don't have that. We have treaties around land, land operations, sea, space, but treaties, of course, are not guaranteed, but at least we have them. We don't have treaties here. We have ICANN. And ICANN is a coalition of the willing. We have IGF. Thank you, Milton, for getting that going and keeping that going. But, this is very much non-binding. It is way less binding than any treaty. And what we're doing right now is all of these superpowers, whether they be nations or big tech, are entering the information era, and they're kind of squabbling over territory and precedent. And eventually an equilibrium will be reached, and we'll have some norms, and everybody will do what they can to observe those norms so that everyone else will be incented to do the same. That's what we do to avoid, let's say, nuclear weapon proliferation, and it works. That doesn't have the force of law, but it does work. We don't have that for the internet yet. This is the messy decades in which we will find the norms that can eventually be codified and observed. I wish we could get there faster. Thank you again for inviting me. I hope to see some of you in Kyoto next week. And I don't know if the organizers want us to take any questions.
Yes, we have a question on the floor.
Well, I just come here to thank Paul Vixie to give a keynote speak here, and this is an interesting talk. And I saw some of the people have a question. So, Paul, are you ready for a question?
I am ready for questions.
Good. Is anybody want to ask a question? Come in. Come here in the microphone. And say your name to Paul.
Hi, Paul. My name is Janet Hofmann, and I have a simple question. What is the evidence for international law not applying to cyberspace or the information space?
Evidence for a negative in this case is how long it takes to get law enforcement cooperation for a cross-border request. It can take months, it can take years. Some countries don't answer at all, where they might do so if some law had been violated that was also a law of the destination country. You know, if you murder somebody and fly to some other part of the world, you can probably be extradited, or at least evidence can be gathered. Law enforcement will cooperate because murder tends to be against the law everywhere. Same thing with child sex abuse. But internet crimes don't have that status. You cannot get recourse. There is no accountability across national borders for bad acts which are internet carried, internet propagated, internet originated, and internet delivered.
Thank you. And we also have another question from the floor.
Anybody have a question, you're always welcome to this microphone, please.
Hello, Paul. This is Milton Mueller. I was very interested in your extended discussion of how DNS has been a site of struggle for control. And I was hoping that you would give some indication of where you think we should go next. What do you think is the best way in terms of a policy that ICANN might adopt that would resolve some of the growing complexity and the problems that you described?
Well, since ICANN is a multi-stakeholder model organization, it is not specifically meant to support any one interest. In other words, it's not mostly for governments, mostly for companies, mostly for end users, mostly for nonprofits, mostly for civil society. It's for everything. It's trying to find a way forward where we can all be productive, and this wonderful thing can enable a better future for all. And I respect that. I think that ICANN could get ambitious in one area in particular, maybe two, but the one I'm thinking of is as these protocols that are meant to bypass firewalls get rolled out and they become the norm, we're going to face some real surprise from people who didn't used to have certain data able to leave their secure house or whatever agency, suddenly finding its way out. I think that no one who has been involved in that, in creating all of these new bypassing protocols, had any interest in secure private networks. But we are a constituency that ICANN should observe. They should know that we're here. And ICANN has got a very powerful office of the CTO now. It's grown over decades into something that is true peer of the realm technologically. And if ICANN were to decide that creating some new protocols, sending ICANN's own experts out into the community, out into the IETF, out into meetings like this one, to gather information about what's needed and then propose solutions, we could have some protocols that would allow you to negotiate. Hey, I'm a web browser. Where am I? Am I on a place where I'm just free to do as I please, or are there rules? What are the rules? If I wanted to observe the rules, I as a web browser have no way to know what those rules are, because there's no one who's been involved so far who has the resources necessary, because this is a years-long project. And, you know, I have a day job. I got other stuff I got to do, so it won't be me. This is something ICANN could really get behind. I'd like to see them do it.
Any more attendees have any question?
Paul, allow me to ask you a question. My question is, first of all, I remember when the U.S. Congress is talking about the SOPA Act, and you and Vincent, you are against the, the government of the law to redirect the domain name to somewhere which is not unique, to somewhere else. But I think you knew that after the SOPA, so many governments go through the court to asking the government or the ISP or whatever to redirect the domain name to somewhere, which is not supposedly the DNS should do. So what do you think is after the SOPA till now, what the technical community against, but it's actually already happened in this ordinary life now. So what do you think about that?
I think that I understood even at that time why the U.S. government was trying to protect its economy, the economy of the United States, by making certain websites off limits. What we tried to show in the sort of the white paper and everything else that we did is that it won't work, that filtering at the DNS level as a way to command policy, to command changes in behavior, won't work, right? It's something that you can do as a service. And indeed, if you look at Quad 9, they have DNS filtering as a service. If you use Quad 9, you have the ability to say, please filter for me. And that means if one of their users wants to have certain things filtered for them, they can ask that that be done. And that works. My own technology, RPZ, is meant to make that possible. But that's voluntary. If you're going to impose a regime of sanctions in the information realm, and you try to do it with DNS, it simply won't work. You can't. You cannot do that. And that's what we were trying to say, is there will be much harm and no actual change in outcome along the lines of what they were hoping for. I think that's still true. I think when you start down the path of trying to control what will pass in and out of a country, that's a very different problem of a nation. It's a very different problem than controlling what goes in and out of one family's house or one company's network or one government agency's network. I understand why a government would want to impose controls. I'm not unwilling to workshop this problem with people who want to know, gee, what would be the right way to solve it? But DNS won't work as a solution to that problem.
Any further question? If not, let's give the Paul Vixie a big applause. Thank you very much for your speech.
Thank you, Mr. Vixie.
Hope to see you in the Kyoto.
Thanks again to Mr. Vixie for insightful sharings, and we will now take a short break. The next session will begin at 11 UTC+8. Please be back on time. Thank you.